Ever thought about how us humans learn? What is learning in general? Well, when you learn, you take in and remember information, then apply it to other situations. But our brain is just a bunch of neurons and muscle. So can this be applied to computers? Well, we invented the AAN, or Artificial Neural Network. For example, here we have a cat, and his name is David. And I'm going to build an AAN, which is a model, that predicts how much he will love you based on where you pet him, such as the back, ear, tummy, and tail. And our inputs can either be on or off. Now, our output is going to be the probability of how much David will like you. Now, if we fiddle with the inputs, we can see the output neuron changing. And let's see what's inside this mythical machine. So here it is. Now, I'm sure you can see these lines, and we can assign weights to all of these. Now, and we can also assign inputs, which can either be 1 or 0 to each of the neurons, or input neurons we'll call them, and we'll call those inputs biases for now. Now, we can assign our weights to different values, and a weight is just a number. So here we have 0.77, 1.75, 2.02, and negative 1.71. And these numbers are somewhere on the lover meter, so the weight 3 is pretty high because if you pet him on the tummy, he'll like you more. And we can call our output P, which is the probability blah blah blah. And we can then take the weighted sum, so we do weight 1 times bias 1, and then we add it weight 2 times bias 2 plus weight 3 plus bias 3 and so on. And then this here determines the probability of how much Lister will like you. Now there's also something called a layered network. So here we have our cat and the list of inputs, and we can flicker the inputs on, which has the weights for each assigned input. And then we have this other layer right here, which also has a bias C2. So, if this probability says 95%, then this bias is 0.95. And then that value is plugged in for all the inputs for the sum of activation, which goes to this final neuron, which predicts how much David will like you. And in the end, we can come to something like this, which is called a digit recognizer. And you can see how each neuron or bias is connected to all the other neurons. And each of those connections has its own weight. And this middle layer here, or the hidden layer, looks for specific components of, say, the number 0, which has a loop, or 9, which also has a loop. But they also detect numbers like a 3, which has 2 loops, or a 1 which has a straight or vertical line. So if we draw something like a 2, it predicts that a 2 is most likely. It's about 90% it's 2. And we can test the accuracy of the neuron by doing weird numbers. Like in this case, this one is a bit weird. It doesn't really detect it's a 1. I think it's just the software I'm using, but